So here's an old project of mine that I worked on a long time ago. I wanted to show. I was unboxing stuff. So it's the Tamiya 135 scale PBR boat, quite famous in some movies like Apocalypse Now and so forth. Through research, I found out that the hull of that boat is there's quite some good research behind it. So it's quite an efficient, simple, fun. I really like the form factor and the layout on top. So I say, let's play around with it. So that boat is not powered by a propeller. It's powered by jets, jacuzzi jets. And that was the challenge because it's easy to make an RC boat with propellers. It's been done over and over, but the jet was a challenge that Tamiya offers a pod that you just, with a suction cup, you just place underneath and you've got a pod with a propeller, a waterproof motor and battery unit, a pod, and you can do it. Then drilling and putting propellers here would be easy as well, but I wanted to do the jet. The way the jet works is the motors, diesels in real life, are always turning the same direction, and to reverse the boat, there's a baffle that swivels and that redirects the water exiting the jets, and that creates reverse thrust. I've never seen a kit that would reverse the motor to reverse the boat. It's always the baffle is being activated. If it's a propeller, we can reverse it, but on jets typically, I haven't seen it. So I found a kit online. It's a Hugohk, and I bought the kits from him. So here's, he uses some kind of SLA or polyjet printer. So here's his impellers, brass shaft, motors, and he had some electronics that didn't work for me, but I used my own. And his coupling. So his system is pretty clever. He solders some brass tubing, you put some oil on top, the gravity feeds the oil so that, you know, it lubricates the shaft. However, I disagree with the coupling. Using set screws, it doesn't matter how tight the shaft fits in the bore, there's always a slight gap, and when you tighten the set screw, it throws the alignment slightly off. That is noticeable at high RPM, at high revolutions, that is noticeable, and it starts to vibrate. So this entire hull becomes like a speaker box, and it's very loud, and the vibration actually disintegrates the welds, like the plastic bonding and whatnot. So this is my 5th iteration at the time when I abandoned this project. So these are sinks to catch the oil. I was using vegetable oil, and it leaks to ends. There's a little of tolerance in the shaft. There's a steel shaft in there, so the oil will leak in front and the back. To avoid having oil in the inside, I put these little sinks to catch the oil. The instructions say to mount the motors firmly, then put the mounts of the motor against the hull, then epoxy them at the end so that you epoxy after the alignment has been done. I've done this. This is some flexible silicone, so there's some give. However, like I said, I suspect that those couplings are not the greatest for high RPM. On larger RC boats that have jets, they don't use a solid coupling, but they use two parts that are united by a rubber part. So the rotation can be transmitted by any slight misalignment or imperfection is taking care of the rubber, and therefore there's less vibration, and it's much better. So I wish there was a flexible coupling, but at this scale it's very tricky. I would have to look. I did this project quick and dirty during the, when we had to stay at home. So I did not use these polyjet housings because they were made for a specific boat, a much larger one. So I 3D printed my own housings, which were intended to fit and match the Tamiya hull as close as possible. So obviously I did not glue the back plate that Tamiya has here in the back. I went with this design where I could have insertable, swappable nozzles. Since I was using tank electronics, it means that I would slow down one side to make a turn, and to reverse, I would just reverse the motor. So this was the challenge, is like, can it be done? I'm going to reverse the jet, meaning the water is going to be ingested from the back and shot through the opening. Notice that the Tamiya molded the intake louvers, the grills with very fine ribs. So this was great because it's like the real thing and it's proper at scale. So again, water at this scale, 135, it's behaves a little different. Of course, at a larger scale, it's much easier, but at this scale, all kinds of weird things happen. For example, I had to prime the jets before placing. When I would put them in water, there would be air, it would cavitate. So you had to prime the pumps first. Once they were primed, meaning the air is out and water has filled the chamber, then it would work great. So the issue of reversing the motor, the jet, and having this ingestion here is that in the water there's always little debris and things, and since it's quite a tight room in there, the danger would be, what if debris go in there and jam the motor? That's not cool, because the motor, if he has one motor hindered, would turn in circles in the pond and I would not be able to get it, or it would be stuck. So bad experience with that. And when you play in public ponds or places, you're not always able to swim or walk in there without getting in a lot of trouble. So I played around with the nozzles. The first nozzles were round. There's straight opening with a strangulation. I tried different sizes. It was so-so. Then I tried a squished output. So-so. And then I said, well, I need to block it because of the debris, like I was mentioning earlier. So I put in there like a bullet-shaped in there held by fins. And the idea is like, well, at least it filters the larger debris, or, you know. And I tried those, and then I narrowed the output. So that increased the velocity. It became more efficient, so a bigger bullet straight on the face of the propeller. So this is my seat in the pant engineering right there. It's like I'm, you know, kind of visualizing the hub from the propeller straight against the bullet, and I'm not using any type of computer simulation of engineering knowledge here. I'm, you know, really just making a guess and then trying it out, which is kind of fun. Those are very easy to print. Within a couple of minutes, you got a new design, try it out, print a pair. And then I went further, a bunch of different iterations of angle, length, and different size of bullets in there and shapes. And at the end, I ended up with this design here. I was plagued by issues with the electronics. Like I was using at the time a board that wasn't that good, so it would stop responding at times for no reason when there was a surge or too much of a load, and you had to reset the board every time it was. So I played in a small pond where I could retrieve it. But here's what I learned from it. I got a couple of videos, but there was some extreme satisfaction. So as you see, there's a slight angle, so it's shooting inward. And the reason for this is to be able to turn. So when you have the output, because if you just shoot straight, it's going to take a big radius to make a turn. I tried sharper angle, less angle, and this is what I ended up with. I was able to pivot turn this thing like a tank, like very nimble, tight turns. It was great. Again, the electronics were an issue, the vibration and the mount is an issue, but I was able to make this reversible jet work. And it was fun. The third issue was the priming, that I don't know, to solve this with a different shape of the chamber or having a way to prime this thing. But it was fun, and this is where 3D printing is really a beauty, that we can test things and sometimes prove things that are, you know, initially when I talked to some of my colleagues at the time, said, no, you don't reverse a jacuzzi engine. There's no, of course, it's not as efficient as going forward, but the reverse thrust was enough to be able to tank steer this thing and do reverse it. So anyway, that was a cool project. Thanks for watching.